This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video we are going to look at how to multiply and divide things from the set of complex numbers. So if we look at multiplication first, we'll take two numbers from the complex set. Z1 is equal to A plus BI and Z2 is equal to C plus DI. We can write their product, Z1 plus Z2, equal to AC minus BD plus AD plus BC times I. Now we're going to look at an example of this and how this works. So we'll look at 7 plus 3i multiplied by 2 minus 5i. So the way we're going to attack this is we will multiply 7 by the second bracket, which is 2 minus 5i, which we can see here, 7 times 2 minus 5i. We will then go back to the first bracket and take 3i times the whole second bracket. So we get 3i times 2 minus 5i. Now it's a case of multiplying numbers together. So 7 times 2 is 14, and 7 times minus 5i, well, the way we do that is 7 times minus 5 is minus 35, and the I will stay the same. In the next case we have 3i times 2, which is 6i, again the I stays the same. And then we will have 3i times minus 5i. So we have 3 times minus 5 is minus 15, but we also have an I times an I. And this I times an I will become I squared. Now, this goes down. The 14 minus 35i is going to remain the same. But we'll have plus 6i minus 15 times minus 1. So I squared is equal to minus 1, and this comes from the fact that I is defined as being the square root of minus 1. So if I equals the square root of minus 1, if we square both sides of that equation, we will get I squared is equal to the square root of minus 1 all squared. Now the square root and the squared will cancel out and they will leave us with our minus 1. So the next line then, this becomes a case of adding and subtracting complex numbers, which we've seen in the previous video. So we gather our real parts of this complex number, which is our 14, and our minus 15 by minus 1, which is a positive 15. So here are the real parts, and we then have the imaginary parts of the complex number, which are minus 35 and plus 6. So we can see that this line, the second from bottom line, is the exact same as the definition above, the AC minus BD. In our case, A times C gives us 14, and B times D gave us 15, AD gave us minus 35, and BC gave us 6. Then it's a case of just adding these natural numbers or adding these integers together to get 29 minus 29i. Before looking at division of complex numbers, we need to define what the complex conjugate is. So if we have a complex number z equal to a plus bi, the conjugate of this complex number is written as z bar. So z is equal to a plus bi, z bar is equal to a minus bi. We change the sign of the imaginary part of the complex number. So some examples of this, if we have z is equal to 2 plus 3i, then z bar is 2 minus 3i. If z is 4 minus I, z bar is 4 plus I. We can see we're only changing the sign of the imaginary part. And we can see if z is equal to 9, which is a complex number, it's just its imaginary part is 0, z bar, it is still 9. If z is 6i, then z bar is minus 6i, again changing the sign of the imaginary part. So if we look at division of two complex numbers, z1 is equal to a plus bi and z2 is c plus di, we have z1 over z2 is equal to z1 times the conjugate of z2 all over z2 times the conjugate of z2, which gives us this formula here, ac plus bd plus bc minus ad all times I all over c squared plus d squared. Now this looks complicated, but we'll see in an example that this is very doable. So again, we need to note that we are multiplying above and below on the fraction by the complex conjugate. The reason for doing this is so as to not change the value of the fraction. So if z1 is 3 plus 2i and z2 is 1 minus I, we get z1 over z2 is equal to 3 plus 2i over 1 minus I. Now we need to multiply by the conjugate of the bottom line. Now the conjugate of 1 minus I is 1 plus I. So we multiply above and below by 1 plus I. Now this becomes a case of multiplying complex numbers together, which we've seen in the previous slides. 3 plus 2i times 1 plus I is equal to 1 plus 5i, and 1 minus I times 1 plus I is equal to 2. This will give us a half plus 5 over 2i. It's important to note that if we multiply a complex number by its conjugate, we will get a real number.